So it's my great pleasure to introduce Eileen Crimmins. Um, Eileen is a professor at the University of Southern California, and she is the director of the Center for Biodemography and Population Sciences. It's a joint center between USC and UCLA. Eileen is very well known in her field. Um, she completed her PhD in demography at the University of Pennsylvania. She is a member of the National Academy of Sciences, the National Academy of Medicine, a fellow of the American Association for the Advancement of Sciences. And she's served on the advisory council for the National Institute of Aging as well. I became involved in the health and retirement study around 5 years ago. And we as the Department of Lab Medicine and Pathology are very involved in studying biomarkers with regards to how we can use these biomarkers for diagnosis of diseases, understanding mechanisms of diseases, and also figuring out how we can use these biomarkers for curing diseases. Since my involvement in the health and retirement study and working with Eileen and other collaborators in HRS, what it has helped me think about is also expanding the utility of biomarkers and figuring out how we can use these biomarkers to understand social determinants of health, and what role we can play in using the biomarkers we use in the traditional diagnosis of diseases, and also think about the broader societal context in the distribution of biomarkers, and also the role play in influencing policy decisions on a more broader level. So I'm very grateful for my involvement and collaboration with Eileen over the last few years. And she's going to be talking about the social, psychological, behavioral, and biological risks in aging, findings from the health and retirement study. So welcome, Eileen, and take it away.
Thank you, Bharat. I'm really happy to be here, even if only virtually. The best thing that ever happened to the health and retirement study, I think, was meeting Bharat and dragging him into our world and getting him involved in this. I met him at a meeting in Washington a number of years ago, and the second I met him, I knew he was, in a sense, an answer to our prayers. We've dealt with a lot of laboratories and a lot of people who run laboratories over the years, and we've never met anybody who was so, who had such vision and intellect, and then standards. We actually love having the lab in Minnesota because Minnesota has a workforce that has strong standards for good production of data. So we're delighted. I visited in person a couple of years ago and spoke to the people who are in the demography group who now have an NIA center, but I'm happy to be here in this department. So Bharat told me that his group doesn't normally think about social determinants of health, and that it would be good to introduce this topic. So I'm here to make this case that health problems linked to aging. I study aging pretty much exclusively, although I think it occurs over the whole lifespan, but that health problems linked to aging are both socially and biologically determined. And the social factors may be more important in many ways than people think who don't study social factors of health. But integrating biology into understanding these social factors really helps you clarify the mechanisms by which social life affects the aging process. Because if health changes, there is a biological change, and the social factors have to get under the skin through some biological mechanisms. So understanding the biological mechanisms helps us to clarify where interventions might take place. That we don't talk really about curing aging, but delaying aging was something that, or delaying the health consequences of aging would be something that would be policy relevant. So I'm going to talk about the social as well as the psychological determinants of health today. So I've coined this term social hallmarks of aging. It was in some ways a response to biologists who had termed a set of underlying factors as biological hallmarks of aging. And I make the same case that there are these social factors that actually are determinants of virtually all the major aging health outcomes. And that these social factors include low social economic status, being a member of a minority group, adverse life events, traumatic events, adverse psychological status, and then adverse behaviors. And I think of these factors, oh, sorry, that's in the wrong place. I told Bharat this had happened to me. All of a sudden, I pressed my machine and it went to the end, sorry. I've been having trouble with this computer in the last day. That these factors are fundamental causes of poor health. They're connected to many aspects of poor health. They influence health from childhood through later life. And there are lots of pathways. Economic circumstances operate through living circumstances. They operate through having access to healthcare. They operate through stress. So there are many, many pathways through which the social effects actually get to biology, and then through the biology actually work to affect the health outcomes. So this is kind of a model of the way that people in the social sciences look at health and aging. That we have large multidisciplinary models. You know, we don't use experimental data. We use observational data. We follow real people in the real world over long periods of time. So we need lots of variables in our models in order to control for all the mechanisms through which health change might occur. On the right-hand side, I have the set of outcomes, health outcomes that we typically investigate in these large studies, all of which are aging-related outcomes. And then this is just a heuristic model where there's some hint of the pathways, but not all arrows are drawn, but that there are these basic underlying demographic factors that work to influence health behaviors, the use of healthcare, psychological factors, and the likelihood of experiencing adverse circumstances. But now with the integration of biology, we actually have begun to investigate a much more complicated model where we put in multiple aspects of biology between the social factors and the health outcomes. So what we've been able to do with collecting data that Bharat has basically been the lab that has produced the assays that we use in our analysis, we now have information on genetic endowment, which precedes everything because it comes from DNA. It's a GWAS analysis that we've done. We have indicators of physiological dysregulation, which are basically your normal clinical chemistry type biomarkers, indicators of cardiovascular, metabolic, inflammatory functioning, immune functioning, organ functioning, hormonal change. We have a lot of indicators of this dysregulation that can occur with aging in any of these areas. Now, for many years, people have integrated this kind of set of biomarkers using measures of allostatic load, biological age, a variety of indicators that have shown to be important in predicting a variety of health outcomes. That it's also been shown that modest amounts of dysregulation across a number of these areas can be just as fatal or health affecting as a very large dysregulation in one area. So we have tended to make indicators that combine physiological dysregulation across many systems. Now, I said earlier that the biologist had talked about hallmarks of aging, and they're really talking about biology at a molecular and cellular level. And so we have just begun to introduce molecular and cellular changes that are linked to aging in our models. And the gray box in the middle here is the one that we've been working on most recently, and the one that Bharat is heavily involved in right now. Telomere length is one of the indicators of molecular and cellular aging. Epigenetic changes that we have examined DNA methylation, and I'll talk a little bit about that later. We have an indicator of mitochondrial functioning, mitochondrial copy number. Right now, we're in the midst of getting data on the RNA transcriptome. Bharat, as I understand it, had 300 cases left to do out of our 4,000 we were doing, and then the pandemic hit. So we're hoping that is something that we're working on in the next couple months. And then our aim is to hopefully get at cell senescence, proteomics, and metabolomics at some future period when we actually perhaps both get more technological ability to do these things and more money to do these things. So this is the model that we're really fitting, saying that you have your social factors and they work through all of these biological factors to affect downstream health. So what I'm going to do today is just briefly show you the link between the social hallmarks and multiple aging outcomes. I'm going to link the biological measures to aging outcomes, and then summarize by saying how the variability in the aging process that I can measure here is explained by both social and biological factors. So as the health and retirement study is the source of the data that I'm going to use, this is a longitudinal panel survey of people over the age of 50 that it was begun in 1992, and people are interviewed every 2 years. We hope that people have blood collection now every 4 years, but the pandemic has made this a difficult year to do that for sure. We refresh from the bottom, so they're new people age 51 to 56 every 6 years. We collected the blood that this is based on in 2016 when the sample, from those in the sample who were 56 plus. So that's the basis of the data. The health outcomes that I'm going to look at include multimorbidity. I could do individual diseases, but really one of the things people have been looking at in aging is this factor that indicates the presence of multiple diseases. So I look at 5 different diseases and just sum up, how many diseases do you have? And this has actually proved to be interestingly a pretty important measure. It's one of the reasons I believe Americans have worse health than people in much of the world, because they have more multimorbidity. It's not that we just have higher levels of individual diseases, but those diseases tend to be concentrated in certain people in the population. And then physical functioning loss is measured by the number of impairments in activities of daily living and instrumental activities of daily living. So activities of daily living are basic functions like needing for eating, dressing, bathing, moving, whereas IADL is are functions that you need to live independently, being able to shop, go outside, use transportation, those kinds of things. We also are highly involved in examining cognitive functioning, and my measure of cognitive functioning here is really dysfunction, so that all the health outcomes are bad outcomes and all the signs would work in the same way. So it's based on MMSE type testing, and it's a cognitive score, and here it's reversed. And then mortality, one of the reasons mortality isn't the best analysis perhaps right now for this study, because as I indicated, we collected the blood in 2016. We only have outcomes at 2018, which is just 2 years later, and we actually have a fairly low level of mortality in just those 2 years, and that's sometimes people don't want to spend their last year of life participating many hours in a survey. So I think we need a little bit more data to actually do a better analysis of mortality, but that's one of the outcomes I'm going to look at. So this is an indication of how strong the relationships are between social factors and the 4 health outcomes. And what I've got on this table is t-statistics. Now, you don't need to really look at the numbers. The point is, the darker they are, the stronger they are. The redder they are, the more positive they are. The bluer they are, the more negative they are. And it just gives you an overall picture. I've listed all the what I would consider the social factors on the left hand side there of the table. So I consider being a member of a minority group an indicator of social and economic status. And then I have education. We have an indicator of low childhood SES, which means you had financial problems in your family. You may have had to move because of someone losing a job. Your parents were low educated. It's an index based on 6 different measures. Childhood health is self-reported. Childhood hardship is an indicator of whether you had certain experiences in childhood, like not living with both your mother and your father, and being exposed to trauma of your parents were physically abusive to you. Psychological outlooks, because of the fact that I'm interested in how psychology affects downstream health. These are measured years in advance, so they're 4 years in advance, and they're depression, chronic stress, and a negative psychological outcome. And then for health behaviors, I have obesity, smoking, and drinking. And what you see is a lot of red across the board, some of it fairly dark, and almost everything works the way you would that I would expect it to work. Now, this is an easier way to see the outcome of those regressions. This is a decomposition of how much of the R-square is explained by each of these sets of variables. And so I can explain almost 30% of the variance in mortality here. And the biggest factor explaining that is demographic, which is age and sex. But you see there's a role for each of my other variables, the SES variables, the childhood health and hardship, the psychological variables, and the behaviors. And that's true for pretty much each of these set of health outcomes, of the 4 health outcomes, they're quite differential. So for instance, cognitive functioning is much more strongly estimated from the SES variables than it is even from the demographic variables, age and sex, that there's much, SES is the strongest set of variables there in explaining the cognitive loss, whereas SES is not as important in terms of the number of diseases. It explains some of the variants, but not proportionally nearly as much as it does in cognition. So the point of this is that, yes, these social factors are related to all of these health outcomes, but there's somewhat differential relationship across the different types of outcomes. That's not totally surprising to me, given the etiology of all of these different outcomes, but it is something that is somewhat novel to show how differential it is. So now we get to the, so I can conclude that it's related to all the 4 outcomes. There's variability, and there was actually a strong association of psychological measures there, which is somewhat stronger than I might have expected, frankly, but it's quite strong. So now I'm going to say, how does the biology relate to the social hallmarks, and then how does it relate to these outcomes? So we're going to use a measure of accelerated biological age, which is based on 15 markers, which I'll show you in a minute. And accelerated biological age is the difference between your biological age and your chronological age. So it's an indication of how much faster you are aging than people, other people in your age range. And then the molecular and cellular measures that I'll include are telomere length, mitochondrial DNA copy number, and then epigenetic age, which is a measure that is similar in some ways to the biological age, but it's based on the DNA methylation. And the measure of epigenetic age I'm going to use here is probably the one most commonly used in the literature. It's been around since 2013, and it was developed by Steve Horvath, and it's his epigenetic clock. There are lots more of these clocks, and they're probably, some of them are better than this one now, but these are all probably going to be re-estimated in the coming decade is my guess. So anyway, this is the most commonly used one in the literature. And then for the last analysis, I will look at DNA genetics effects using polygenic risk scores, and I'll describe the 5 polygenic risk scores that I use at the end. And for that one piece of the analysis, I'll only use the white population because we're just not sure how to use the polygenic risk scores in the non-white population. So this is the variables that are included on our measure of biological age. So there's 15 indicators here: metabolic, cardiovascular, inflammatory, liver, kidney. But some of the indicators are clearly very linked to aging, and the reason that we collected them was because of their relatively strong, or the reason we assayed them was because of their relatively strong link to aging. And then that includes the DHEAS, the IGF-1, pro-BNP, and then we have an indicator based on 5 different cytokines, and an indicator of immunosenescence that comes from the flow cytometry that Bharat did of the CD4 over the CD8 cells. So those are somewhat newer indicators, haven't been included in biological age before, but those are in the measure here. And this measure, just to show you, this biological age measure makes sense in terms of the social differentials. I'm just showing you raw differences by education here, which show that people with less than 11 years of education have a biological age that's almost 2.5 years older than their chronological age, whereas people with a college education or 16 plus years have a biological age that's almost 1.5 years younger than their chronological age. So it's a fairly strong relationship. And then I see race differences on the other side, where you see non-Hispanic Blacks have a biological age that's about 2 years longer than their chronological age, whereas on average, the white population is close to its chronological age, but a little bit younger. If I just say in a comparable way to the social factors, how do the biological factors do overall in this? So it's this combination of factors that were in a regression equation. How did they do overall in explaining the variance in these for health outcomes? And here you see the mortality with the biological, all those biological variables, and age and sex as the demographic variables. I can explain almost 25% of the mortality and somewhat less of each of the other measures. And the biological age makes a contribution of somewhere between 5 and 10% of the variance explained. And so it varies somewhat across the different health outcomes, and it does explain some, but certainly not the majority of the variance. So now, does the biology help us explain the social differentials as well as this downstream health outcomes? Because the reason we are interested in the biology is because we really want to understand how the social factors work. So the expectation would be, if you had all the biology that through which the social factors were working and you put those things in the equation, what you would do would be eliminate the effect of the social factors, because the biological factors would take over the variance essentially. And so this is when I put everything in the equation together, the biological factors, the demographic factors, and then my sets of social hallmarks of aging, I see, yes, I do increase the amount of variance explained, so that overall in mortality, I'm up to about 32, 33%. And that the biology explains pretty much still it's 5 to 10%. It takes away a little bit from the explanation the social factors had previously, but not a whole lot. We still have a lot of social variance in these outcomes, and a lot of the variance is explained by remains explained by the social factors. So if you don't look at the demographic factors, you think of those as sort of neutral, you still have more of the variance explained in all of the outcomes by the social factors than by that wide range of biology. So we are adding to our understanding of how social factors get under the skin, and we're adding to our understanding of how of the role of social factors and biology factors, but we still have a long ways to go in actually understanding all the mechanisms and all the variability. This is just the T statistics. So I went backwards in this presentation before I showed you the table with the T statistics and then the summary. This one, what I'm really doing is showing you the relative role of the various biological measures that accounted for the biology that was the box in the blue slide prior. So what you can see here is the top line that's red, and that actually had an important effect in the equation, and that's the biological age minus chronological age, which is that set of 15 factors, aging related factors, metabolic, cardiovascular, inflammation, kidney, liver functioning. And those are the things that are actually doing the explanation that the underlying molecular and cellular mechanisms aren't doing all that well. Telomere length isn't significant at all, and epigenetic age acceleration is appropriately signed and significant in predicting multimorbidity and IADL and ADL difficulty, but not in the other two. So it's really the top, the bio age minus chronological age. It's that level of biology that's doing most of the explanation of these outcomes. So people are always interested in how much does genetics do in explaining these health outcomes. So in the health and retirement study, we have constructed polygenic risk scores based on the literature. For here, I'm going to use 5 scores: the cognition score for the cognitive outcome. For diseases, I use coronary artery disease and myocardial infarction and diabetes. And I use the longevity polygenic risk score for both ADL and IADL functioning and mortality. So, and as I said, this equation is the same equation as before, but it's only run for non-Hispanic whites. And the thing that you might be interested in here is the little red piece. So that's the piece that's attributed to the polygenic risk score, or genetics is what I'm calling it. And so that it is quite significant in, I'm sorry, it's actually not significant in the equation, but it does at least explain 2.5 to 3% of the variance in mortality. It's bigger there than in the others. So in general, these polygenic risk scores actually explain a relatively small amount of the actual health outcomes in human populations. But if you can include the genetics and the biological factors here together in terms of the variance explained, that's about equal in mortality to the other end after the orange bar on the bottom, which is the social factors. And so they come out to be approximately equal, at least in that equation for mortality. They remain lower in the other equations. So people are always interested in how much does the genetics really do, because we've spent a lot of time at least trying to get into that, what was once a black box for us in trying to predict health outcomes. So in summary, I'd say the social hallmarks are strong and persistent determinants of these outcomes, even with a significant amount of biology controlled. The biological hallmarks of aging, measures that we actually have available, do not appear to play a very strong role in predicting this variability in human aging. And the genetic polygenic risk scores aren't even significantly related to the health outcomes in this sample. This is thousands of people in these samples. The more downstream biology seems to be quite promising. It is related to the health outcomes. It does explain significant variance, and it does seem to play a role in understanding what the pathways are through which social factors actually influence the health outcomes. My point is basically that the biological approaches to understanding aging should incorporate some of the concepts in the social hallmarks in order to better use experimental design to understand the pathways through which aging occurs. So I think we need if the biologists joined and tried to use experimental design and incorporated indicators of stress and lack of resources and understood more what mechanisms those have in experimental research, it might help understand better what we should incorporate into human research. So I think there's a long way for integration here. And it's basically, this is a good time to try to do that, because actually until about 4 years ago, the biology of aging at the National Institute of Aging just didn't work on humans. They have now actually decided that to work on humans as a model organism, which is the time to move forward with this. I understand that it is hard. We may not have perfect measurement if you're actually in human cohorts where you actually need to understand complete life circumstances. It's very hard to get measurement over the entire lifespan that adequately portrays the biology as it has been experienced. I think we as social scientists need to try to include as many of the biological hallmarks as possible so we can get better at measuring these things. And perhaps we are missing still some of the pathways that will be better explained as we move forward. Maybe the RNA-seq will give us another little insight into the picture. But it's also true that it's hard for the social scientists to really unpack the meaning of the social hallmarks of aging. And we also need to do better at that. Again, it's hard to collect comprehensive data on lifetime circumstances. If childhood and midlife are important in terms of data on aging. So for instance, I myself have worked on the 1918 flu epidemic and shown that the 1918 epidemic had long run outcome in terms of health after the age of 60. For that population. It's possible that right now, early life experiences and exposures to people who are just in utero at this point, they can have an effect 80, 90 years down the line, and that is difficult to measure. We have not been well set up to measure those things. So we actually need to study data over lifetimes, and we may need to get much better at data collection and linking over time. And the other thing is, like the biological hallmarks, the social hallmarks are really in many ways inseparable. Experiencing trauma, having low SES, behaving badly, all of those things tend to go together. So it's often hard to figure out which of these pieces actually are the social, the fundamental social factor, and then the consequential social factor that's affecting the health outcome. So one of the ways that we might do better is actually by looking at people who are off diagonal, people who have unusual groupings of those factors. So low SES people in childhood who actually become high SES in adulthood, low SES people who don't experience any trauma and have lots of support. So that's one way that the social scientists need to move forward. So that's my presentation, and basically I think there's a lot of future in this work, and that we're only sort of beginning this serious integration of biology and sociology, and I look forward to another decade of work with Bharat over integration of new biological measures. So we are supported by the National Institute of Aging with many grants, and the Health and Retirement Study is also supported by the National Institute of Aging, and I have nothing else to disclose. I have no other support that would be an issue here. Thank you.
Thank you very much, Eileen. Any questions from the audience? Any questions for Eileen?
Yeah, I'll start, Bharat. This is John Crossan. I wanted to talk to you a little bit about the availability of healthcare. And one reason I'm asking this is that right now, people who live in rural parts of the United States have really serious problems in getting healthcare compared to urban population. And actually, the life expectancy of people living in rural America is 3 years less than those living in urban areas. And is your healthcare consideration included in the demographics, or is that a separate thing? And if not, should it be separate?
That's a complicated question. We certainly we always are including it in our models. Now, how you actually include it in regression models is somewhat complicated, because the more healthcare people use or have used, typically, the sicker they are and the more they die. So if you just used a regression model, you would say, oh, the outcome is clearly the more you use, the worse you are. So that doesn't really make sense. But we do use indicators of control of hypertension, control of cholesterol, access to healthcare. Yes, we do put in, do you have this kind of insurance or that kind of insurance that pays for drugs, or a variety of things. And I totally agree with you. Healthcare is a gigantic issue. Health, I think, is probably really the issue. And healthcare is a piece of that. And geographic differences are expanding. They're getting larger. There's the well-off are getting better. The poorer part of our population is getting worse. Life expectancy is pulling apart. Gains are only being felt among those who are highly educated or better off. Those with low levels of education have actually not experienced gains in life expectancy for 20 or 30 years. It's relatively shocking. I think COVID has helped to bring forward some of the differences in healthcare and health that exist in the population, but it's something that has existed for a long time and we haven't done very much about it. We actually just finished a volume on aging in place that is about things like rural and urban differences and state differences, and I think in geographic differences, those are the future of discussion of health and healthcare. So Dr. Crossan, I think you hit it on the head.
Okay, we've got another question. What about nutritional aspects? How are they captured in the data set?
I actually didn't have any nutrition in that model. And I could. We have actually, the Health and Retirement Study did a large nutritional survey, specialized survey in 2013. And we actually have done analysis, and what we see is across the board, Americans do not eat in the recommended daily allotments of virtually anything, except they overeat in red meat and sugar. Beyond that, they're not close to eating what they should. And we find that there are large differences by social and economic status, and that those things are related to the biological markers. I didn't have that in this equation, but I know that all to be true from other analyses that we've done. And, you know, I always find it hard to interpret some of the, you know, work that comes out of some of the modeling that says nutrition is the major changeable factor in terms of improving health outcomes, but the sort of work out of the WHO group tends to have those kinds of statements in it. So it's a factor. Partly it's represented here in obesity because that's clearly one of the outcomes of poor nutrition, but you're right.
Hi, this is Leo Firk to Eileen. Thank you for this incredibly informative talk, and many accolades to Bharat, which we love him too. So we're,
We all love Bharat.
I know. He's just a one of a kind. So just a personal belief on my part is that a lot of the health disparities, which then generate into aging disparities, is due to economic disparities, and that then leads to educational disparities and a sort of a vicious cycle of inability to change that. Did you look at, and you have some of that obviously in your data, but did you look at income levels for various people?
Yes, yes and no. I mean, we use a data on poverty and in childhood particularly. You know, one of the things about studying aging is income changes with age in ways that don't have to do with that have to do basically with aging. So if you're a couple and you get Social Security and then one member of the couple dies, well, all of a sudden you've lost a third of your income. So it looks like you've had an economic disaster. Well, you probably haven't had an economic disaster. You've had a shock to your system because somebody died. So, and the other thing is that some people don't have income anymore, they have wealth. And so income gets to be a confusing kind of measure to use across a population that's both working age and non-working age. And our people are above the age of 50. So people in their 50s and 60s and early 70s may still be working, but beyond that, people are not working. So it gets all tied up with age and family status. So yes, I believe income is the mechanism, but it was probably income throughout life more than the current income. And so that's why we don't stick it in the models. And that's why we sort of, as social scientists, we tend to use education more as our basic indicator of SES, social economic status, rather than income. It's not because we don't think it's really the income, but that it's the education that made the income that you had throughout your life. And then that really was that income and made that job, and that job had certain job characteristics, and it did or did not have health insurance attached to it. So that that becomes the basic mechanism through which some of these other things occur. Now, in terms of cognitive functioning, we may think education really has a direct effect on your brain, but we don't think it has some real direct effect on your development of disease. We think that comes from the whole lifestyle that's connected to it. So yes, I totally agree with you, but it's sort of just this issue of how you do it in equations.
Thank you. That was very helpful.
Eileen, there is one other question on the chat. Have you considered microenvironmental factors such as accessibility to fast foods, especially in minority communities and lower SES communities? The communities with
everybody's hitting on all the things that we think are important, and I don't have these in this equation, but I have lots of other papers. And one of the things that we have done at USC is we have made what's called a contextual data set that we joined to the health and retirement study. So we have actually done, we've figured out for each census tract, for each county, how many fast food places there are, how many fresh food places there are, how many supermarkets. And we've also done a lot of other things like healthcare availability and air pollution. And, you know, we have a lot of factors in there, but we indeed have linked those things to diet. And it is true that there are food deserts. There are places where it is hard to get fresh food without having transportation to go a ways. And it does result in community diets that are much worse. And minority groups eat worse in the United States. There's no quite, Americans probably eat worse than other people, but minority groups within the US and poor people eat worse than other people in the US. So I agree, that's a factor. And we do include it in models where we're looking at what makes diet. We do include what makes what's available in your neighborhood, so to speak. So yep, that's another factor. Leo wants to say something.
Yeah, I got another one. So, sorry. So again, these studies are so elegant, and Bharat has kept us in the limelight on much of this and informed. Is anybody doing the 0 to 50-year-old parallel?
You're right. One of the things that the National Institute of Aging is doing right now is emphasizing middle age and moving down. And it's very hard to get a good study that spans a lifespan that is 100 years for a cohort. But we now have this approach to sort of having a study of young people, adolescents, a study of middle-aged people, it's called MIDAS, and then a study of old people, and kind of piecing them together and trying to say what happens, here, and what can we extend it through middle age and later age if we look at the young people, and can we put it all together? That's kind of where we are right now. And I think, the National Institute of Aging has had a significant amount of money recently, and I think that is one of the things that is important in their trying to understand aging, because it doesn't help to really pick up 80-year-olds for whom most of this is water over the dam, and you can't go back to square one. You have to start at square one to move forward. So that's one of the things that's been important. The other thing that's really been important in the last couple of years for aging work is people were not allowed to intervene to change the pace of aging, because aging was not a disease that was treatable. So the FDA has now allowed treatment, so to speak, of aging. It has said you don't have to have it declared as a disease, but we understand that everybody's aging, and we can actually allow some trials to try to actually delay some of these things that are related to aging. So that's been one of the reasons why we've developed this measure of biological age, because the FDA has actually said, well, that may be a reasonable outcome to look at and to watch as we intervene as we use trials to see if you can actually delay some of these aging outcomes. So that's a real change. There are changes that occur that allow research to move forward in leaps and bounds, and I would say that that's one of them. So there actually are some trials of well-used drugs to try to so-called delay aging at this point, and I think they're precursors to what might really happen in the next 10 years.
Thank you.
And it's not that you don't want people to, we're not looking for immortality. We're looking for the decline in health problems, basically. Right. That's what I mean by delaying aging.
Quality.
Yeah.
Well, the COVID situation, with all the stress our department is feeling, I don't know if Bharat has conveyed to you, we're on the hook with the state to do 10,000 tests a day. So I think all of that is a occupational hazard for all of our molecular people and me.
We check in with Bharat all the time to see how things are going in Minnesota.
Great.
Because we also have been affected by that, but
Indeed.
No, it's in some ways you're on the front lines and I'm on the back lines, because I don't go to work at all. I work in my office at all,
right?
Because I need to let the guys that have the labs take the percentage of spaces that are allowed to have people in them in any given day.
Sure.
So us computer guys can just work from home.
All right. Any other questions for Eileen? I want to thank you, Eileen, for this wonderful talk and really stimulating discussion.
You're welcome.
You somehow make all these complex models seem so accessible to people who are not familiar with them. So it's been a wonderful talk. Thank you again for
I enjoyed visiting with you this morning.
Thank you.
Thanks.
All right.
Bye-bye.
Thank you, everyone.
And
Bye.
stay safe,
everyone.
stay well.
Yeah.
You as well.
Bye.
Thank you.